Hello guys, how are you? So today I'm going to explain you end-to-end an NLP projects which is based upon this spacy and it's called name entity recognition. So I'm going to go with this some traditional way and approaches. So what is that projects and why you require that projects and how you can do with that projects. So I just wait. I'm sharing screen and I hope my screen is now visible. So here actually I'm going to explain the problem statement about that spacy model. So if I write on the net spacy inner model, then you will going to see so many content documents and all those. Okay, so spacy has a one pre-built function that's in your components, and by utilizing those in your component, automatically you can do do a fine tuning of any model. So sometimes my live screens get stopped, so I have just need to come back here again and again. So initially you have need to give some problem statements why you have need to utilize all those and something. So I'm just zooming my screen. Here I will put down that in here object. I hope my screen is visible here because sometimes it's not get updated. So this is the in-ear model and what is the problem statement for this? You have need to find the custom entities from unstructured data. And unstructured data means any text data. So what are the use cases of those models? They have so many use cases, as I will write here use cases for those model. Why actually we require the NER type system. So first one use case to identify custom entities. Just ignore those spelling. Identify custom entities. Custom entities means look, see spacy have model and they have already trained their models. They have some models names like I will explain. Spacy have already trained so many models like en core web small, en core web large. So en means English and web means train on various website sources, and large means CLG or SM means small modem or model or large model. Okay, so and those models are already predicting different types of context. Those models are predicting different type of context, such as I will show you here. Already they will go into location, country name, then date, time, then they also going to give show you some percentage, name of organization, world organizations, name of capital of countries. So they have already trained 8 to 10 entities. But suppose if you have a business case, such as your data is financial data, financial domain data, or medical domain data, or it's a legal domain data, and you want to identify or you want to catch this some relevant entities from those specific data. Suppose if it's a medical domain, then if maybe you want to find the what that unstructured or text data containing the brand of those product names, then a generic name of those product names, then what percentage of doses content those data containing, and what is their model dimension. So those are the some basic entities you maybe want to find from those medical domain data. Suppose if it's a financial data, then maybe you want to find the total amount from receipts. Then you may need to find the address of that receipt. Maybe you need to find the date from those receipt, or you may need to find the um, what we can say GST from those receipts. So you can add your own terms, and it's a legal. Then there are so many terms in that, like SLA, service legal agreement. Then term condition maybe there. Then maybe there how many validations or so many conditions. So those are the particular entities may happen between those particular data. So let's say you have medical domain data and you want to find those. If you got the any unstructured documents, either it's in the CSV file, PDF file, or all those. Initially, I will tell you what should be the process. So after that, initially you have need to collect all those unstructured or text data. So you have one text file, and that file containing all those products names, descriptions, whatever may be products, and it may be it may be going to show you some descriptions related that products. So this is the one text file, and it's containing so many text data. Then you should have another file, and that file should going to contain specific entities for those data. Means here we are going to create the label data, create label data. Actually, that type of data required for this spacy model. Excuse me. So how to create that label data means to train any spacy model, it required the data into the annotations format, and that format they required is this is the format. So this is the text. I will going to show you any product names. Take product name as a Ramson trimmer, 5 mm, XYZ will be dimension, and it's very excellent condition and good for any gender. So this may be the product description or text file. I have just taken the very small example. So space model required the data annotations in a such a way that I will write here annotated data format. Annotated data is equal. It will going to it's required the data into the list format such that initially it will going to take this text as it is. Okay. After that, it will going to create some entities. So entities will be the another list, and in that list entities will be another let's suppose it's a dictionary, and in that dictionary it will going to consider the another list. So here are your some entities like brand. So you have need to pass here brands start and end index. So suppose in this case Ramson is the brand. I hope my screen is visible, or otherwise it's a waste of time. Yeah, it's working. So here is the brand, and suppose Ramson is the brand. So I need to find the start and end index of for that Ramson brand. So start index is the 0, and maybe ninth index is the end index. So model will going to learn that if suppose that particular word is coming at specific positions, then those words considered as a brand. Then it will going to we have need to pass another here list, and in that I have to mention trimmer. Means I'm going to create another entity, it's generic name, and once again I have need to pass here it's start and index, like generic names start at, suppose it starts at the 11 positions and ends at the 20 position. So in this way space model requires the format. Okay, I hope you are getting this very well. I have just need to remove that comma. Okay, so in this way you can create so many labels for those examples. And suppose maybe if you have huge number of documents and all those, then this is just one annotations for that one examples. Maybe you have 1 lakh such examples, 1 lakh such product names, so 1 lakh such financial documents, or 1 lakh such legal documents. So you create for all those documents or those unstructured data, text data, such format. And how to do this, I have just created it now manually, but you can write Python coding regex function. So how to do this by using regex function. I will also share that code later. By regex code, it's very similar. In that regex code, you have just need to pass the find method. So suppose if you have that text file which is containing here, here is your text file and it's containing lakhs of those product names, and you have need to create on a one list for brand name, and in that brand name it will going to contain all those various types of brand names or your entities. Then you have need to create the another list for generic name, and it will going to contain all those uh, entities related to generic name like injection, then trimmer, and all those. Here brand names may be Ramson or any other type, Cipla and all those. And once you create the, then you have need to apply the regex functions, and you have need to just say for that re.find from those text files. If a particular brand names occur in that text file, then please label it as means you need to give the options re.find it or start index and end index. Then it will going to give the automatically. So this is the just a simple Python code, but I'm just explain how you can do this. So once you have created, I hope my screen is still, yeah, it's working. Once you have created all those trend data, then you have just need to pass that trend data. Means suppose this is your annotated data file. Actually, it's a training data file. Then you have need to uh, train test split. Means you have need to keep some data for training and you need to pass some data for text. Okay. Once you have done this, then you have need to utilize some species span filter function, because space will not going to work if your model is saying Ramson as a brand also and Ramson trimmer as a whole generic name. Means it's not going to work for those overlapping concepts. So space model wants specific, this should be only brand and this should be only a trimmer, should be only a generic name. If there is overlapping between those two names, then it will not going to work for those. Hence for that we require the span functions, and it will going to filter all those brand. So it will just going to keep that unique particular name for those brand as a brand, trimmer as a generic name, then 5 as a doses content. Okay. Once this is done, you have need to train test that file. I hope my screen is visible. Then you have need to just to go to the here species model, and you have just need to search here spacy config file. Sorry, once you came to here, so this is the species config file, and in that file they have mentioned all those things like where is your training data file, where is test data file, so which vectors you are utilizing, are you utilizing GPU or not, then what is the batch size for your models, then which corpus data or which embeddings you are importing, and and how all those are happening. So once you download that file, then you have just need to open that file, and yeah, you will going to see uh, those are the just main components added, the training directory, test data directory, and what is the batch size, which optimizer it's utilizing, and initially warm up rate, like when should that start, at what condition it's a compounding batch side should stop. Okay. Then I hope my screen is here. Then you have just need to just need to save that config file to the specific directory, and you have just need to pass that one command, that space init fill config base config. So through this base config it will going to create a one another new config.saveg file, and in that saveg file it will going to add all those concepts like what should be vector size, from where you have utilize all those data, where should be your data shared, what is the learning rate, and all those. So it will going to modify that file, and it will going to add some functions or parameters here. Okay. Once this happen, then you have just need to this in this way you will get. So which vectors it is utilizing, or which arguments you are giving, how your data validations is happening, and which drop off rate utilizing, or gradient descents, epoch numbers, how many epoch numbers you are giving, and where your logging is happening, console loggers, the various types of Adams parameters like beta 1, beta 2, L1, L2, decay rates, and all those. And once this is given, you have just need to pass that command. Python yum spacy train spacy.config means it will going to take all those commands from spacy configs, and you have need to pass those train data file and test data file. So this command is paths.trains, so it's related to only training of that file initially, as we have created all those components, and test means those test data files as we have created those initial component. And here you can also pass those max number of epochs and all those. Once those systems completed, automatically your species models will be saved to the your local directory, and you can initialize that model automatically. And in this way, simply you have done, or you have just done the fine means sharing of your all those creation of all those models and all those. And when you pass that command, train command, automatically it will going to show you some evaluation metrics like uh, what is this precision core, recall score, then f1 score. I will just show it from the net. There may be so many users have already uploaded a file. So yeah, you will going to get all those in this way. So for particular tokens, how much precision recalls and all those. So it's a very simple one. Actually, in this way, actually you will going to get all those scores. I think someone had their question. So yeah, if your precisions or recalls based upon your specific conditions where you are going to give the importance, if your precision is greater or recall is greater, then automatically you will get the best results for all those things. I hope my screen is visible and sharing, because whenever I'm coming here, it's stopping to share. And yeah, then you can load your model, you can pass unstructured data to your models, and model will going to predict those entities, and you can do some human evaluation metrics also, or based upon your matrices also you can tell to them. So here are some basic methods that while training all the species model, what you have utilized, and which training means which models you have utilized. So I'm going to tell you in the next part. Still I will write here species transformer config file. So spacy has already one wrapper, so it's a transformer wrapper. So in that config file you have just need to pass uh, that transformer model, bert base and case, or roberta model. I think my screen is not shareable. um, and while creating those, I think it's not giving here. I'm just you need to fill some here blanks like uh, instead of CPU you have need to utilize GPU. Yeah, and if you want to focus on the accuracy, then you have need to utilize an accuracy method. And here you will going to see that you have passed the transfer model, so utilizing PyTorch. Then it will going to utilize some species transformer layer, and at the last, when you fill that species config file, then it will going to take a bert model, roberta model as a fine tuning process. And be sure while doing all those, you have also new species transformer model like species and core web TF models. So actually this model is fine tuned based upon the your data annotations tools. So this is the very simple. And actually what happens, well, when you do the fine tuning all those models, it works really very well, but while giving the interview or doing any type They may be ask why you have utilized transformer model. Tell me the architecture of BERT model. Is it encoder based or decoder based? And what is its embedding shapes and dimensions and all those? And why you are utilizing only BERT model? How it's different from the decoder model and all those. So please be prepared for that. And in the next video, maybe I'm going to cover how BERT model will going to work. So so just my screen I have need to slide here. So BERT model is very simple. So it has some embedding layer, then we do this position embedding, then we do the sentence embedding, token embedding, and it has some sentence classification layer like token separation and sentence separation layers. And BERT model utilizes some dynamic, based upon the condition it utilized by dynamic masking or static masking, and it's learned from all those. And it's a very means not that much simple, but it's a very really nice architecture, and in the next video I'm just going to cover that architecture. So I hope I have. And once your model has been trained, you have just need to utilize your Flask API, and in that Flask API, you need to keep your model. You have need to create some user interference where user will going to pass that unstructured data file. Then whatever once unstructured data file is passed, you will going to load that file by using a PDF reader or any text reader. And whatever text you have got, you will going to pass those text to the species model. And through this species model, you are going to capture those entities by using some Python code. And yeah, you will going to show those entities for, means you will create some use case like you are utilizing those entities for searching methods or showing to the users for categorization of all those products. And once you have created those Flask API, then you cannot do a Flask, you cannot directly put a Flask into the production. So you have need to apply some web server gateway interference, like because Flask will not going to create its own means application replica. So you have need to utilize some GUnicorn, where if there are thousands requests are coming, then GUnicorn's worker will going to create the thousands workloads, and it will going to create indirectly thousands applications, and for each user it will going to act or work independently. And at the last you will going to create a Docker image, and Docker image also very simple. You have just need to import some Python file or Python slim package, and after that you have just need to just wait. After that you have just need to build that what we can say Docker image by using Docker file, and you have just need to pass copy your whatever files, Python coding files you have stored into your directory. You have just need to pass those into the Docker file, and at the last you have need to pass some Docker build command, so your Docker container will be built. Then at the last you have need to push, you have need to go to the any cloud server like AWS registry or Azure registry, and you have need to tag your image to those registry ID, and you have need to pass those container. Once your containers pass there, if you are using the Azure, then you need to utilize web app, and web app automatically create the endpoints. Then it will going to create the Kubernetes clusters to handling all those managing requests. If utilizing uh, AWS SageMakers and all those Fargate and all those, then it will also going to create the automatically cluster serverless browsers and automatically handling all those requests. And once it's done, yeah, your application is deployed automatically. After that you can create so many CI/CD pipelines and all those, but I will going to cover all those into the next lecture video. I hope my voice is clear. Sometimes I'm seeing my system is lagging, but don't know its work. Or and this is the end-to-end deployments of the spaces model utilizing Flask API, Docker images, and some basics theory. How you utilize the transformer architecture into the spaces file, how you create the data annotations, how you do the evaluation of models, and how you put into the production. So I have covered all those end-to-end. If you have any doubt or questions, please try to ask me in the comments, and have a nice day. Bye bye. I'm stopping video.